Okay, let's start. I'll hand over to your host.
Yeah, thank you so much. So first, good evening, everyone. Thank you for coming today. And I know some of you are driving from San Francisco, and including the Kirill. So thank you for coming, and welcome to DTALK. And DTALK is a global community lecture series, and initiated by Talking Data and Synced. And the Talking Data is and bringing the high-profile individuals to discuss about data science, machine learning, and artificial intelligence. And this is the episode 3. For the episode 1 and episode 2, we have the data science from Akron talking about fintech. And for the episode 2, we have the Foxconn CEO Terry Gold talking about industrial AI. And in this episode 3, we have Kirill talking about the data science process. And and for Talking Data is China's leading third-party data intelligence solution platform. And with the Smart Data platform as the core of its data intelligence application ecosystem, Talking Data empower enterprises and help them transform to achieve the data-driven transformation. And Sync is Chinese first media entity reporting on machine learning, artificial intelligence. And today we're so honored to invite Kirill, and he's the founder of the Super Data Science, and also, as everybody knows, he's the top instructor from the Udemy. And he has like more than 550,000 students has taken his course, and with 4.5 stars reviews, and I'm one of his students as well. I took the Data Science A to Z from Udemy, and I think that is one of the best data science course, especially for the new learner. So let's welcome Kirill.
If you want, I can go and you can continue chatting. See, that's the point of these things, right? Like, you get to meet people, and ultimately networking, especially in a field like data science, is probably one of the best things. What I love about data science is the community is so welcoming, so warm, so supportive. Thank you very much. You just check this? Okay, awesome. And there's like, in other environments sometimes, like, I don't know, they're a bit more cutthroat, and they don't support each other as much. In data science, I've never seen that. You have a question, you go online, who's had this experience? You go online, you ask a question, you get an answer, you get like 50 answers. Who's asked the question online before about data science? Yeah, so you've got CLARA, you've got Stack Overflow, you've got all these other resources where people are willing to help each other. And here, you actually can meet and maybe do a project together, and you like support each other in person. This is the best, right? Okay, so moving on to today's presentation. The data science process, a systematic view. We're gonna have, this is gonna be like the index, so what is actually gonna happen today. It's gonna be quite long, by the way, and then you'll see why. So number one, we're gonna have an intro, so you get to know like who I am and what we're all about, if you don't know yet. And then we'll talk about the data science process, just quickly an overview of what's coming up after that. Then the main part is deep dive stories, and it's going to be 25 tips that I'm going to share, and it's going to be in the form of stories. You'll see what I mean when we get there. So we're going to make it fun, not one of those. So it's not super. So it's not like not absolutely not technical, but it's not super technical. It's somewhere in between, but we're also going to make it fun. Then we're going to have a bonus. So highly recommend sticking out to the end. If you really need to go, you can go, but otherwise we're going to have a bonus, and that also applies to guys watching online. And then we'll have a Q&A with the help of our wonderful host. Okay, so a quick intro. Welcome, everybody. You got to introduce yourselves to each other. And this is me. This is, you can see it's not really true. I don't have orange hair, just an orange beard. But that's our designer's interpretation. Funny story is that I can't get rid of the beard now, because they're using this image on their website. Okay, so what I like is vegan burritos. Except for today, I tried. Who knows flying falafel in San Francisco? Yeah? Okay, 4 people. Amazing. If you're ever in San Francisco, which I assume you sometimes go because you live here, flying falafel, the best. So it's kind of rivals vegan burritos. Next one is rock climbing, and I like also structure. And in terms of structure, like kind of a bit of OCD, like everything has to be in line, but it has its benefits. You'll see that today, after leaving this room, you're gonna have like the data science process in your head, all 5 steps, everything related to it, super structured. You're never gonna have that question, and you're gonna be able to teach your grandmother about the data science process. All right, just a quick intro about Super Data Science. So this is a company where we teach data science to, as mentioned, 500,000 plus students worldwide. As you saw, a couple of people here, about maybe half the audience have already taken some of our courses. You can find them on Udemy, on superdatascience.com, and other platforms. So there's a couple of examples of our courses. Deep learning, what else? Machine learning, computer vision, Tableau. You can teach like health in the workplace. Then we also have a conference, Data Science Go, which happens in San Diego in October. So this year is happening in October, and we'll tell you a bit more about that towards the end. Okay, part 1, the data science process, which is also called the data science project lifecycle. I like to keep the energy up. Who's excited about this? Who's not excited? Put your hand. Yeah? Yeah? Okay. Who's excited to finally learn this and like have one thing in your life, hopefully more than one thing, but one thing for sure, down pat and never have to worry about it? Say yes. Yes. I didn't hear you. Say yes. 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 Okay, there we go. Let's do this. Okay, so data science lifecycle. This is our diagram. No, it's not. This is a complex diagram from Microsoft, and we're not going to use it. I'm just showing you that there's different interpretations of the data science process, different ways you can represent it, and this is one of them. Too complex. We don't want to like try to remember this thing. So here's another one from DataFlare.training. Like, I don't have anything against them. I'm sure they're wonderful when you get to know them and understand them better, but that's not what we're going to be using. A bit too complex as well. Here's one that's a bit better, 5 steps, but ultimately they're not exactly the right steps, well, according to me anyway. So what I'm getting to is that there are many interpretations of the data science process. What you'll learn today is my interpretation, the one that I've come up with through my experience teaching and so on. And a lot of our students use that interpretation. It's actually, that's the main structure of a book that I wrote earlier. So you'll see that that's just something to keep in mind. When you're talking to somebody else after this, they might have something else in mind. But yours is the good one, just so you know. Okay, so we're gonna have 5 steps, and right now we're gonna have like identify what these steps are as an introduction to how we're gonna dive into them. And the way we're gonna introduce them is how I discovered them throughout my career. So I never started from the first step actually. Started from the second step. And the second step, surprisingly enough, is actually prepare your data. And who's done data preparation before? Yeah? Okay, you guys know that this is one of the most crucial and fundamental steps of data science. You can't really do data science without data preparation. Then, next step is analyze the data. So once you prepare it, run your machine learning, run other algorithms, and find out the insights from the data. Then visualize the data, and so you can present it to people, so you can actually get those insights and represent them in images, something that people understand, not just numbers. At the end, you present your findings. You gotta convey that information, because if you got a lot of insights and nobody's gonna act on them, then what's really the point of your data science? And finally, the very first one is actually identifying the question. And you'll see why I only found out about it late just now, but that's the way I discovered it for myself. So the first two together, identify the question and prepare the data, take up about 80% of a data science project in terms of time. That's where you're going to spend most of your time. The next two are 20%, and the final is 80% again, right? So if you want to take a photo, please do. I think we'll share the slides. I'm not 100% sure about this when it'll happen, but I see some people taking photos. Anyway, so why 80, 20, 80? Well, it's because after you've done the preparation and then you've done the analysis and visualize, all of a sudden you're like, all right, I'm just going to present it. But actually, it's a lot of work to present to somebody. It's a lot of work to convey the insights. And I call this 80-20-80 rule of Yao, because I discovered it from one of my mentors. Well, at the time, it was my mentor, Yao Tan, who's right now Senior Vice President of Financial Crime and Analytics at DBS Bank. And this is his photo from LinkedIn, and I really like the background. It's like the hair didn't fit into the middle one. He put it in, Yao, if you're watching, no, nothing personal. So that's his quote, and it was really cool to find that out. But why I also brought this up is because this is how we're going to structure today's presentation. So this is our data science process. Now you have this. This is how we're going to go through this. Identify the question, prepare the data, analyze the data, visualize the data, present your findings. We're going to have a section devoted to each one of these, and we're going to dive deep into them. And the other thing is, to make it fun, we're actually going to have a story, at least one story, for each one of those. So those are going to be like raw facts and figures. We're going to analyze what somebody went through, what experience they had. And all these stories are actually coming from the Super Data Science podcast. Who listens to the Super Data Science podcast here? Okay, awesome. And so some of these people you'll recognize, you may have heard them already. And if you haven't yet, then at the end I'll show you a slide where you can, in which episode you can find each one of these stories. Okay, so part 2, we're diving deep into the stories. All right, everybody clear so far? Okay, cool. So stage 1, identify the question. We want to understand, what is actually the problem that the company is pursuing? What do they want to find out? And so the reason why I actually, remember I was showing you how I found out about this late? Do I need the microphone for the live streaming?
It's fine.
Do they need?
Thank you. Yeah.
Can they hear without the microphone?
Yeah, I actually
Yeah?
You're just using the microphone outside.
Like I really don't think I need a microphone for this audience. Huh? Is that okay?
No, it's fine. You're just using the microphone. You don't have to put the microphone.
No. What I mean is, can I just do this? Can I talk like this? Can they hear me there? Oh, okay. Sorry, guys. All right. Just not used to holding a microphone. Anyway, so what's happening here is that why did I find out late about this? Is because I worked at Deloitte when I was starting out into data science. Deloitte is a consulting firm, and what happens there is when you get onto a project, there's already an engagement letter and a scope of the project outlined. So as an analyst or a data scientist, once you're introduced to a project, you already know exactly what you need to do. You don't have to talk to the client. That's already done for you. The directors, the partners have done that, and they know exactly what needs to happen. So you get in and you just do from step 2 to step 5. So I never actually thought that step 1 existed. For 2 years I was working at Deloitte, and then later when I left, and then I started hitting these roadblocks. I was like, why? I would start a project, and then all of a sudden the project would change. All of a sudden I would do all this analysis and I would answer the wrong question, and I would spend weeks doing a project, and then I present the findings, but then the internal stakeholder would be like, that's not what we wanted. Even though the insights are great, that's not what they were after. So identifying the question is an extremely important step. That lays the foundation of everything you do. And our example here is Ruben Kogel. So Ruben was on the podcast quite early. He was on the very first episode, then he was on the 39th episode again as well. And what he shared in his second appearance on the podcast, he's the director of data science at Visco. It's like an app that, does anybody use Visco? Yeah, it's an app for photos, right? Yeah. So you can edit your photos, add filters and so on. They have millions of users per day. It's a huge app. And so what he does at Visco is he's the director of data science, and they analyze. So as you can imagine, they have lots of data. They have a ton of data points. They collect every time you click on a photo, they collect data. Every time you use a filter, they collect data. And so one time he had this project where the stakeholders or the shareholders of the company, they wanted to know better how to distinguish people that actually sign up for the premium version of this product. So they have a free subscription. Anybody can use it for free. But then at some point, people choose to buy it and get additional options and things like that in the product. And so what they wanted to know is segment or describe, provide some insights to describe the people that actually buy the product. And one thing you could do is right there, and then you run off and you start creating your project data preparation, analysis, visualization, and then you present. But because Ruben's experienced, the first thing he did is actually went back to the stakeholders and said, hey, actually, what do you want? Like, why do you want this? What's the business problem that you're facing? You know, like, what exactly do I need to show you, or what you, okay, it's, you want a segmentation, but what question are you trying to answer? What's the problem that you're trying to solve? Because, for example, it could be, they might be trying to see how their behavior changes, and you know, maybe where they're finding that after people subscribe, their servers are going down in certain areas because people are starting to do more of a certain thing than they were doing before. Or, as it actually did turn out to be, it was a problem that they wanted to see. It was a marketing problem, so they wanted to see what do people who subscribe look like, so they can target those people and then sell to them better. But it could have been something else. It could have been like a services problem. It could have been like, all right, how do we service these people better? What do they want after they subscribe? So there's lots of actual sub-questions that you can ask. And so if this is the audience of millions of people, as you can see, if it was one version of the question, maybe the segmentation would look like this. Another version of the question might have looked like this, right? So every time the answer might be different. So you need to drill down and actually understand really, really well what is the business problem behind the analysis you're about to do. If you don't understand that, then you're wasting your time and other people's time. It's like throwing, you know, like a dart at a dart, whatever it's called, throwing location. And if you might get the bullseye, but you might not, because you know you just don't know exactly what they want. So we're gonna go through top 5 tips for this part of the process. We've already mentioned a couple of them. Number 1, understand the problem. Go back, ask questions, talk to your stakeholders, spend some time, right? A lot of the time you'll find that your stakeholders, which can be external if you're a consultant in data science, or it might be internal if you are in a company. Who is a consultant in data science or freelancer here? Put your hand in. All right, 1. Who is working in a company or wants to work in a company as a data scientist? There you go. So what you'll find is that you still need to treat your internal stakeholders as if they were external. You need to ask them everything, write everything down, and make sure they answer your questions. So they kind of expect that you'll run and jump into the answering the problem right away, but you need to spend like 1, 2, 3, maybe 5 days just digging around in the problem. Number 2, develop your domain knowledge. So domain knowledge is kind of like your industry knowledge. What is going on in this industry? Let's say you're working in pharmaceuticals. Start learning about pharmaceuticals, start learning about the different types of data, different types of tests they're on, different types of clients, different types of regulation. The more you know about your domain knowledge, the easier it will be for you to grasp the business problem. And what I like about data science is the skills are extremely transferable. So if you're doing data science in pharmaceuticals today, tomorrow you can go and get a job and do data science at a supply chain or logistics company. Like that, very quickly. And I know this because I worked in consulting, that's exactly what happens. One day you're working on, I don't know, like we're doing geospatial analysis for a retail medical facility that wants to do a merger and acquisition. The next day I was working for a railroad trying to optimize their cold delivery supply network. And the skills are transferable, domain knowledge isn't. So that's kind of your weak point, but the good news is that if you spend a weekend reading about your new industry or whatever industry you're in, you've already like gotten 50% up to speed. You spend another weekend, you're already 80% up to speed. So you just need to consciously focus on that, and not one way to talk about domain knowledge is to wait for these problems to hit you and then learn the domain knowledge. But if you proactively go and put the work in beforehand, everybody in the business will appreciate it. They'll be like, this guy or this girl, they're so proactive, they already know a lot. They'll come to you with a problem and you'll already be able to talk their language. That is really cool. That is called like going over and above. You want to be a data scientist who's not just crunching numbers, but who goes over and above, and your clients, who might be external or internal, you already know half the problems that they might have when they come to you. So develop your domain knowledge, very important. Tip number 3, mine the data or do preliminary data mining. And we'll talk about data visualization for data mining. We'll talk about visual analytics further down. So basically do that. Like when you have the data, even before you start preparing the data, before you start analyzing, before all those steps, you can take your data and throw it into like a drag and drop tool like Tableau. Again, we'll talk about that a bit later. And already get a feel for the data. You know, it might be, like without data prep, it's very dangerous to gain insights. But to get a feel for the data, that's a different story. That's allowed. That's okay. Because data is actually has some secrets in it. And even if you visualize it without doing the data prep and all that other stuff that we're going to talk about, there still has the secrets, but at least you can see it, right? We are not machines. We cannot understand the numbers, but we can understand pictures. Put it into pictures, or do some, some other data mining, like draw some distributions with Python and so on. Just like understand, is it a normal distribution, or is it a uniform distribution, or is it a Frechet distribution? What's going on there? Just get a feel for your data even while you're scoping out the project. As early as you can, it'll give you advantages. Don't rely on it too much, but get a sense for the data. Tip number 4, inform your stakeholders in writing. This is very important. When you are about to start a project, when you've done those first 3 tips and a couple of steps already, and you know what you're going to be answering, put it in writing, send an email, get a confirmation. Because if you just talk, and you might be best friends, outside of work, but if you just talk about it, and then you do the project, and then like, this is not what I wanted, how are you going to prove that it is what they want? Or especially if there's 5 of them in the boardroom telling that that's not what they wanted. Or if during the project, all of a sudden they start saying, this happens all the time, they start saying, I want this done, I want this additional thing, I want that other thing, I don't want this anymore. No, like if you identify at the very start what they want, you spent the time, you spent 3 or 5 days identifying it, put it in writing, and they've confirmed it, that's it. If they want something else, that's their right, but then that's a new project. Very important, otherwise you will get yourself into a trap. Tip number 5, know how to say no. Like that brings us to tip number 5. So when people want to expand the scope, that's called scope creep. In consulting, it's a proper term, scope creep. It's creeping on you. You say no, because in consulting, they would have to pay more money. Since you're an internal stakeholder, you're an internal data scientist, they don't have to pay you more money, so it's easy for them to ask for more. But ultimately, you're spending more time, and you already agreed to a certain deadline. So learn how to say no, and this also applies to other projects. Like a common mistake that I've done, and maybe some of you have done, if you haven't done it yet, if you're just getting into data science, you will do it, trust me, is saying yes to everything. Because once you, especially if your company is just starting a data science department, what you'll notice is that once you start do first project, second, third project, and you're bringing value to the business, they start talking about it, especially in a bigger business. They'll start talking, telling each other, hey, I had this problem, but our data scientists reduced the amount of time we spend on this from 100 hours to 1 hour per week. It's really cool. And people will start coming to you. You'll have an inflow. If you want to be a successful data scientist, what you'll have an inflow of people requesting your work, your attention. If you're an external consultant, the same thing. You'll have a lot of clients. Very hard to say no. Often we find ourselves in life. You need to prioritize. You need to understand what are the projects that will bring the most business value to the business. Ultimately, if you're a data scientist in a business, not in a non-for-profit or just as a hobby, but in a business, what businesses care about, and we live in a capitalistic world, what businesses care about is their bottom line. Whatever you do should add value to their bottom line. And even if it's increasing their reputation, at the end of the day, it's helping the business survive, it's adding value to their bottom line. So that's how you prioritize projects. You find the ones that add the most value to the bottom line. If you don't know how to do that, talk to your manager, they'll help you. But don't say yes to everything. It's better to do one thing really well than 10 things and screw up 7 of them. That's not going to help your reputation or the business either. So know how to say no is actually better for everyone. All right, so top 5 tips for stage 1. Understand the problem, develop your domain knowledge, mine the data, do preliminary data mining, whether it's visual analytics or other ways, inform your stakeholders in writing, and know how to say no. Very important. Those are just 5 tips, and I'm sure there's definitely more, but that's the most important ones. All right, moving on. Stage 2, prepare the data. What happens here? This is the biggest stage by far. Out of them all, the first 3, remember, take 80%. So the second stage is if your project is, 5 weeks, then this first stage might take up to a week. The second stage is going to take you 3 weeks, just preparing the data. That's how long it takes. And then the last week, you're just going to have fun. All right, so our rock star today is Ulf Morris, Finance Director of Ubisoft. Who knows Ubisoft? All right, okay, who knows Assassin's Creed? Who's heard that? All right, so Ubisoft is the company that makes computer games like Assassin's Creed and others. So he was on the podcast also pretty early on. I have the episode numbers at the end. What Ulf shared, he shared quite a few, actually 2 times about data preparation or data type of projects. But the one that really stuck with me is a project that he did before Ubisoft. He was in a consulting firm, and it's like data science is really fun, guys. Like you can have so many different areas where you can use data science. So their consulting firm, it was like back in the day when the term data science didn't exist. But what they were doing is they were advising a merger and acquisition, where a merger and acquisition is like when one company buys another. So one company was about to buy another company without mentioning any names. I don't even know the names. He didn't mention them, which is rightful. One company was about to buy another company, and so there was another consulting firm that went in to do the valuation. So one consulting firm does the valuation, and they say, all right, company A is buying company B. We need to value company B. Company B might say that we're worth $100 million, or euros in this case. But then company A hires consultants to go in and do the valuation, and they do the valuation, and it turns out that actually company B is worth 42 million euros. And that was the case. They were worth 42 million euros according to these consultants. But then another consulting firm has to come in and do the due diligence on that valuation to make sure that there's no shady business, right? So Ulf was in that company Z, the last one, that comes in to check the valuation. So they come in, they're like, all right, so 42 million euros, we need to check the financials, we need to check everything to make sure that the numbers add up, that, it's mathematics. You just do the discounted cash flow value for the next couple of years and, look at assets, look at other things to make sure that everything works. But the thing is that everybody was already happy with the valuation. Company A was happy, it was a big company. Company B was happy with 42 million euros. And the consultants did their job. Everybody was happy. They just wanted to get this thing along. And so instead of 6 months, so these are quite lengthy things. Instead of having 6 months, Ulf's company only received 3 months to do the assessment of the valuation. Instead of having like 5 or 6 people on the team, they only had 2. It was Ulf and his boss, his manager. So there's only 2 people on the team. And this is where data preparation comes in. The worst part is that company B, when Ulf and his manager asked for the data, what company B did is they printed everything out. Yeah, that's what and they gave him like this huge stack of all the financials for the past 7 years. Go, you got the data, technically. And like even in 3 months, they would have had no time, especially back in the day when you didn't have those scanners that scan everything all the time. They wouldn't have time to scan it, OCR it, do the character recognition and analyze, and they wouldn't be able to analyze it. It's like a dead-end project. And so what Ulf did is, so many companies involved here. So basically, whenever they went to company A, company B for the actual data on a floppy drive, you remember those things, floppy drives, yeah? Whenever they went to company B for a floppy drive of the data, the company B were like, no, like we already gave you the data. And wherever they went in the business, they were already instructed not to help this consulting firm because they just wanted to push the deal ahead. So what Ulf did is he went to the company, this is like a 5th company, that was managing company B's ERP system. So enterprise resource planning, or the customer, the databases basically weren't internal to company B. Not many companies could afford internal databases, or cloud didn't even exist at the time. They were external at a supplier. So Ulf went to that company and said, hey, look, we're doing this due diligence, and we have the right to inspect any kind of assets. And as he correctly guessed, that company hadn't been instructed to ignore them and to make their life harder. And so what he did is he talked to them quite nicely and kind of challenged the database administrator. Can't you guys do better than just send us paperwork? He's like, yes, of course we can. And he put it onto 3 flash drives, 2 floppy disks for him, and he gave it to him. And that's what data preparation is about. Understanding where you can get data. It's a very different example to what we have now, but still, the point stands. Where can you get the data? How are you going to prepare? Are you going to scan those files, or are you going to actually go and do something about it? So they analyzed it, and they did a full assessment, and the company value actually wasn't 42 million, was 2 million euros. So they took it down by 40 million euros, and that's what company A bought the company B for. Just a little bit of data prep makes that much of a difference, right? Impressive story. Now Wolf works at Ubisoft. Data sources, speaking of. Where can your data reside these days? Not on floppy drives, but let's have a look. So data sources these days could be a server, like a database, right? SQL server. What else do we have? PostgreSQL, another type of SQL server. Oracle SQL, another type of SQL server. MySQL, another type of SQL server. SQL servers are very popular, and that's your standard structured type of database with tables. And actually, I like this website quite a bit. It's called dbengines.com. If you look at it ranks the database engines by popularity and by usage. And if you look at top 5, and Oracle, MySQL, Microsoft SQL Server, Postgre, and MongoDB. We'll touch on MongoDB just now. As you can see, these ones are all relational DBMS, database management systems. MongoDB is a document store. We'll talk about that in a second. But who knows any one type of SQL? Who's worked with SQL in any sort of way? All right, cool. Who knows 2 types of SQL? Who knows 3 types of SQL? The thing is, you can keep your hand up. They're all the same. So, my recommendation is learn 2, learn 1, then learn the second one, and then you can pretty much handle any one of them very quickly. The best one, if you're because a lot of you you want to progress your careers, the best one to start with, in my opinion, is Microsoft SQL Server, because even though it's a Microsoft product, they put in a lot of work to build a community around it, so that whenever you ask a question, you get an answer, and there's a lot of experts that are paid by Microsoft floating around the internet answering questions. That's how they promote this product. Very cool. Most of them have free options that you can download and install. The next one is probably PostgreSQL. Is very good as well because it is a tool that startups use, that a lot of startups have opted into because it's completely freeware. It's open source project. I'm not sure it's open source, but it's free for sure. So, another thing I really like. I love this part. Who knows this guy? Put your hand up. All right. Okay, so a bit of insight. Larry Elliott is the CEO of Oracle, and he's actually you don't know these things until you randomly stumble upon them. 10th richest person in the world with $58.5 billion. He was the 6th a few years ago. This is according to this year. You never know. This guy's into yachts and racing and stuff like that. But yeah, founder of Oracle, and this also shows why. Why is Oracle number 1? Not because, in my opinion, others might think differently, but it's not because they're the best database management system, but because they're so entrenched with large organizations. They, a lot of these companies that are massive beasts, they adopted Oracle early, and now it's very hard for them to move to something else. It's very hard to move to Postgre or whatever else, MongoDB, whatever might be better. They can't move away, and they just continue using Oracle and paying their fees. And that's why you will, a lot of the time when you go into an organization, you'll find they're working for Oracle. But it is harder to learn because they don't have such an active community online. Moving on, adding MongoDB here, it's a non-relational database management system. I'll come on to that in a second. Also, your data might be in a CSV file, might be an Excel file, might be in a JSON file. It's a JavaScript object. Who remembers the N? What the N for? Object notation. Thank you. So JavaScript object notation. It's like when you see these hierarchical structure inside a file. When you see one, you'll know it. Well, basically, MongoDB uses JSON format, so it's a good thing to know as well. It's a bit tough to get your head around at the start, but good to know. You can put in your resume. I know JSON. Hadoop, getting more popular, big data systems. Notepad++, it's more kind of you use to open the data source or to analyze data. When you can't open it with a CSV or an Excel file, you use Notepad++ or EditPad, EditPad Lite or EditPad Pro. Those things have unlimited, Excel has a limited number of rows. These don't. It might be online, so Twitter, websites, we do some web scraping, a lot of, more and more data scientists are doing unstructured analytics, sentiment analysis of who's saying what on Twitter, and maybe you need some data from a website that they're not just readily giving to you as a CSV. You just scrape it. You will use Python for that most likely. They have good libraries for that. So that's where your data might be sitting. There's other places, but that's generally what it is. So what is the data preparation process? And I was fortunate enough that even though at Deloitte I didn't learn about I didn't learn about the preparing or identifying the question phase. I did learn a lot about data preparation, especially as a young analyst. They really train you up. It's it becomes something how in the army they train you up to shoot or react. Same thing. You show me a dirty data, instantly these reactions kick in. I have nightmares and PTSD. So ETL process, what is it? It's extract, transform, load. Okay. So what does that mean? Extract is you need to go and find the data where it's residing and you get it out of there. It's usually, as a data scientist, like sometimes you will encounter situations where you're analyzing the data where it is, or you might need to create something that goes into production and that sits and like works on constant business. But still, even in that case, you would extract the data, do the analysis, prepare your algorithm, and then deploy it. So it's always a good idea to extract the data. It's very risky to work with the data in its original source. You screw up one row, that might cost the business millions or billions of dollars. Right? You don't want to do that. It's better to have a copy and work with that. So you want to extract. Plus, that allows you to transform the data, allows you to work with it, mesh it, analyze, look for certain things, look for anomalies, look for outliers, look for missing data, corrupt data, incorrect data. There's 3 different categories. Missing data, somebody forgot to enter it. Incorrect data, somebody entered the wrong thing. They entered the date into the, I don't know, the name column or something like that. Or they entered a completely incorrect number. And you want to also miss for corrupt data that was entered correctly but got lost in the process of some transformation, some moving around, or physical damage, something else happened. And then you want to load it, usually into another server. That's why SQL and other, the different types of SQL are important to know, because not only it allows you to extract data for most organizations these days, they store their data in SQL, but also it allows you to load it back in for analysis that is convenient for you into a relational database management software. And for the transform, you're going to use probably one of these. Well, that's my experience. There's other tools you could be using, but Microsoft SQL Server Integration Services. So not just the SQL DBMS, the database itself, but Microsoft has a wonderful tool called SSIS, and that allows you to load data into a database, and it's really cool. It runs in the background. It's like this. It gives you this visual representation. Really like it. Who's done the data science A to Z course? All right, you remember that from there? Yeah? Yes. It was fun, right? That's one of my favorite parts. Tedious, but fun. This whole place, you see how much time I'm spending on these slides? Because that's how much time you're going to be spending in life on this thing, on data preparation. Python R can also help you a lot with data preparation. Some people are, skip the SQL whole phase and just Python R. That's also an approach. So, okay, so is this clear? If you have questions, we'll have a Q&A at the end. So just if something's unclear, remember to write it down, because there's going to be a lot more on this stuff. All right, so here's an example. This is a real example, not made up. Sometimes I might make up an example for the course, just make up a business case because I can't use a business case from past experience, or make something similar. But this is an actual example. Adlan and I downloaded it. Who knows Adlan better? Oh, okay, you'll get to see just my co-instructor on machine learning course. We downloaded the dataset. This is Google stock prices from Yahoo Finance. Direct download, CSV file. You click the button up at the top, download, and what you can see here is on row 504. Try find that. You only usually find that once you see the problems happening. That's what data preparation is for. On row 504, on 26 April 2015, which looks reasonable, 24, 26, 27, it's not like a duplicate. Bam, what is that? These other prices are stock, bid, ask, bid, volume, and so on. What is that? And it's a stock split, and we looked it up, and apparently that was a Sunday, so there wasn't actually a stock price. If you look at it carefully, you'll see that there's only 5 per week. 17th jumps to 20th, 1st of May jumps to 4th of May. So this was a stock split, which happened on a Sunday, and I think that's, Google did one of its usual things that, it became Alphabet or something like that, or they did a merger. I don't know, maybe it was an Alphabet thing, I don't really remember which year that happened. But basically it was a stock split, and they recorded it there, and the person uploading the data to Yahoo Finance didn't clear it out, and that affected the analysis. So that's one of the examples of corrupt data, right? It's not incorrect. Somebody didn't put it correctly on purpose or by accident. But it's just it could be incorrect as well. You could classify one as or the other. So yeah, that's going to inevitably affect your analysis. So you need to find things like this and remove them, or know how to deal with them. And we're going to have an example just now as well. So just to show you that this happens in life a lot. Top 5 tips. Here we go. Tip number 1. Run QA after extraction. QA is not questions and answers, it's quality assurance. And in Deloitte, in consulting, it was drilled in. You actually run them in pairs. You do the, what's it called? Extraction, and then you, for instance, in your extraction scripts, usually you write a script for extraction, or whatever way you extract it. You have to check, okay, how many rows do I have after extraction? How many rows did I have in the original dataset? First thing you check, right? If the number of rows doesn't match up, something is wrong. You know, very easy thing to do. Another thing you do in your QA is you check, how, you know, like if there was something like, if something like this happened, this was actually quite, you know, lucky and unlucky in a way, because this row didn't ship. You see these empty commas? The tool introduced those empty commas. But sometimes what happens, those empty commas don't get introduced, so that next row gets moved here. You know, 1, 2, 3, 4, 5 values from that row get moved here. Then from that row get moved here, and so on. It screws up the whole file going down. So a quick way to check for stuff like this, you know, like won't work every time, wouldn't work here, but in other cases will work, is you check not the top rows. A lot of people just look at the top rows, are they fine? Look at the bottom rows. Look at the bottom 5 rows. Are they fine? Are they in the right columns? That's quality assurance. So of course look at the top 5 rows as well, just in case. But you know, also scroll through. If it's not a huge file, you know, just take the file and just scroll through it and look at like visually things. Then you can do like, so after extraction, that's kind of like, those are just the main things. Then decide on treatment for outliers. So sometimes you'll have outliers which are incorrect. For instance, you have you know, 100 stores you're analyzing for a company, and all of them did like on average, I don't know, 1,000 sales of a certain product, like maybe it's a car or something like that, or maybe like, you know, like 100,000 products they sold, like notepads or something. But then one of these stores sold 10 million products. So that could be incorrect, right? Then you have to fix it, get the real data, or remove that row. Or that outlier could actually be correct. They might be doing a really good job, but you might still need to get rid of them because it's going to affect your analysis. You need to decide that for yourself. Do you want to report on, you know, these 100 stores, what is going on in general? Then maybe you don't remove it, then you keep use the median instead of the average. But you keep that in mind. So, but sometimes you'll actually remove that outlier because it's going to be skewing your aggregates, and then in your final report you say this outlier was removed. Reformat dates. This is my recommended formatting for dates. It's the one we use in consulting, because you know how in America you have MM, DD, YYY, which I still don't know why you guys do that. Other countries in the world you use DD, MM, YY, which is like logical. But if you do it this way, every computer system will understand. Excel, Microsoft SQL, and there will never be a problem. No computer system will think that that is the date, that is the month. Never. It's always going to be correct. So that's best way to reformat the dates into that. Save your ETL script. If you're running this in Python or Microsoft SQL Server or SSIS, make sure to save the script so you can analyze it later or rerun it later, or somebody can QA it for you later. You've got to save it. You've got to have a auditable trace. And finally, run QA after the load. We ran a QA before the load, then you manipulated the data, run the QA, count the rows again. If you removed 5, there should be 5 less, not 10 less, not 7 less. Then after the load, you can also do things like, now that the data is clean and it's already loaded, you can like run a few distributions. Run a distribution and look at how for instance, you're working with customers, look at the age distribution. Unless there's certain product SKUs, the age distribution is usually a normal distribution. Or maybe you know that a good QA, one of my favorite QA checks, is if you have phone numbers, you take the last digit, not the first, but the last digit of the phone number, and you run a distribution of that. And what should it be? It should be uniform, right? Like it shouldn't be like more 7s and 3s. It should be a uniform distribution. If you got a problem there, something's wrong with the data set. Why are there more people with their phone number ending in a 7? You know, or like take a random letter in a surname. You know, it should be distributed similarly to how letters are generally distributed in surnames. You can look these things up. There's other distribution you can check. But again, check the last rows, check all these other things that we talked about after the extraction. All right, so top tips for stage 2. Run QA after extraction, decide on treatment for outliers, reformat dates, save your ETL script, and run QA after the load. So those are our top 5 tips. And right now we're gonna have a little exercise with this part, run QA quality assurance after extraction. So one of the things we talked about in quality assurance is checking for missing values. Let's have a look. So here's a data set. So you're doing a project, you're a data scientist, officially, congratulations. Meetup hasn't even ended, you're already a data scientist. You're doing a project for what they call venture capital fund that are choosing from 1,000 startups, and they want to invest into a few of them, and they want to pick out the best ones. And so later on, this is from one of our courses, from I think the Tableau Advanced course. So later on, you'll actually do analysis. This is the data preparation phase. And you have this problem. You have some of these fields are empty. What are you going to do about it, right? So let's start from the top. Actually, we'll go left to right. So industry. So you see these companies, City, Ace, and K Electronics, they don't have an industry. So what are you going to do? Any ideas? Like, feel free to put your hand up, please. Yes. Google it. Correct. You know, one way you can do is always just remove the row. But if you can Google it and replace it, and especially if you know it's 1,000, it's not 10 million, you know that there's going to be a limited number. You can already see that they're not coming out at all. You Google it, or you ask, somebody else to Google it. If there's a lot. Or you do some web scraping. Next one, Inception. Well, in this case again, right? Google it. That's the date when they started. Usually you can find. Sometimes you can't find that information. In that case, remove it, right? Because, for instance, Inception, you cannot really. You'll see one of the tools we have later on is replace with the industry average. You can't really replace Inception with an industry average because even though it's a numerical, variable, it's not actually. Well, even though it's a number, it's actually a categorical variable. It's not something you can add up. You can't add up years and take averages of years. It doesn't make sense, right? So not all numbers can be added up and averaged out and things like that. So in this case, you either Google or remove the row. Employees, so that's missing. That's a bit harder to Google, right? It's going to tell you a big number if it's a big company, or might not tell you if it's a small company. But even the big number is probably not going to be exactly accurate. So what you could do here, you either Google it, or if it's available. But if it's not available, what you could do is you could take the average of the whole thing. Take the average of the whole column and put it in there. That's already good enough, right? Especially if in your analysis you're averaging things out. But a better way is you see the industry column, filter by that industry, what is it, retail, and take the average for retail. Or even better, don't take the average, take the median. Because you're probably going to have outliers. You're going to have like something like eBay with tons of employees. And you can see here these are mostly startups. So take the median, because the median is not affected by outliers, or not as much. And so then you put in the median in there, and then you have already something to work with. That's one of the techniques. State, you can Google that. Okay, next one, revenue, expenses, profit, and percentage growth as compared to last year. Who wants to do this one? What would you do in that case? Yes, please. Sorry? Remove that row, okay? Yes, please. Sorry? Companies that are annual report. Yeah, some companies publish annual reports. Anybody else? Yes?
We're grouping, and then based on the group, they can average.
Yeah, take the industry average, right? Just like we talked about. Yeah, so there's a couple of options. Choose whichever one you want. And same thing for growth, percentage growth, right? Yes?
Check Bloomberg.
Check Bloomberg, another way. There we go. What about this one? This one's interesting. Expenses. When expenses is just missing, what would you do? Huh? Calculate it, right? Everybody knows the formula? Revenue minus expenses equals profit, right? So you just, expenses is profit minus revenue. That's, is revenue minus profit. That's your expense. And this actually leads us back to this one. If you're doing industry average for this one, you do the industry average, you can't do the industry average 3 times because it won't add up, right? So you got to do industry average twice for revenue and expenses, for example, and then the profit you calculate. So this is all part of data preparation. This is very simple data preparation, visual. You don't need genius scripts, but this is what goes into data preparation. This type of thinking, monotonous, and the more you do it, the more experience you gain. You know these industry average things now. You know the mean, the median situation, distributions a little bit. There's lots more tricks, and that's something that again you can upskill yourself on, learn, and also through experience you gain. But very important. And actually, it's good to keep this knowledge stored somewhere so you can always reference it for yourself. Because as you move on to new projects, you might forget things that happened before. All right, so that's our little thing done, and then once you're done with data preparation, then you do the analysis, and it's going to be fun, and it's actually going to give you meaningful insights, not random insights. Okay, stage 3, analyze the data. So we did the part that takes 80%, now we're on to 20%. How's everybody going? Good? Nope. Yeah? Okay, cool. Analyze the data. What happens here? Okay, Adlan. So for those of you who don't know, Adlan is a co-instructor on a lot of our courses, or my course, well, our courses together, and he's also my business partner. And he's from France, lives in lives in Portugal, and right now he's in Colombia. Just like we were in Colombia like a week ago, because a lot of people from security science actually are in Colombia, and we're just like having a chill out time there. And then he decided to stay, and then he like, I'm gonna do backpacking. he brought a suitcase, and like, okay. And then he just, and then he found this really lovely village with a beautiful view, and he's just sitting there and just like, you know, doing some work, but like in this amazing village. He just keeps sending these photos, and I'm like, dude, come on, that's so cool. Anyway, he loves the nature. So Adlan, this one's going to be a bit different. Adlan is a machine learning expert. He used to work at Google, before that at Canal Plus, doing some machine learning algorithms. I learned a lot of machine learning from him. I'm not an expert in machine learning. I know a couple of things. He's really good at it. And what we're going to do is, yeah, okay. Who here has ever procrastinated? Come on, everybody, right? Everybody. Who hasn't, right? Everybody has. So this is true story. I procrastinated with these slides. So the next couple of slides are just going to be screenshots from the curriculum of our machine learning course instead of like really prettied out slides. Don't think that I'm trying to sell it to you or get you to sign up. It's just the easiest thing that was today, like 2 hours ago for me to do. And I'll show you some other courses at the end as well, so you don't feel that I'm biasing you towards our course. But it will help you understand what machine learning is all about. All right, so machine learning has lots of branches. In this presentation, this course has started out with 7 branches, and we're actually going to talk about, I think, 9 branches, or mention 9 branches. This is available online. I'll show you the link, so it's like you can see it there. Well, data preprocessing, we kind of talked about that a bit already. In machine learning, you got to do a few more other things apart from just data cleaning. But here we got regression. Regression is one of the branches of machine learning. Who's already done some machine learning? Put your hand up. Yeah? Okay, cool. Who's absolutely new to machine learning? First time you're learning about it. Okay, cool. So machine learning is, you don't have to do machine learning for data science. Like in these 5 steps of the data science process, there are steps that you can skip for your career. You can, and we can talk about that towards the end. We'll have that slide again. So for instance, you don't have to do machine learning. If you hate programming, because machine learning is usually Python and R, if you hate programming or you're completely not interested in it, you can skip it and you can just like focus your career on identifying problem, data preparation, then visualization and presentation. And we'll have an example of that just now as well. But if you're not skipping that step, then machine learning is kind of like the new data science. I wouldn't just make that statement. That's what I'm saying. It's kind of, because you can definitely have a career in data science about that. But in terms of popularity, it's definitely taking over. And before data science was the sexiest profession of the 21st century, now machine learning is the most satisfying. Like people doing machine learning, they're the most satisfied in their jobs. KD Nuggets ran a survey on that just recently. And the salaries are extremely high for machine learning experts, like as well as data scientists. Anyway, so regression is one of the branches, and we all kind of like seen in high school, simple linear regression, multiple as well, there's polynomial, support. We're not going to go into each one of this, but they are, as you can see, different types of regression. Support vector regression, decision tree, random forest, evaluating regression models performance. So what this stands to say is that there are lots of different ways you can analyze your data. Pick the one that you like. Have a couple in your arsenal. Don't have to know them all. Kind of learn about all of them just to know which ones work for you, which ones are the most popular ones. But then, pick the ones that work the best, the ones that you like. Classification is when you already have classes, and then you want to add new data points or investigate data points and add them to your classes. For instance, you can have a class of people who didn't buy a product, and then you want to classify them based on other attributes. That's like age, revenue, demographics, location, and so on. You want to classify, are they going to buy in the future, or are they not going to buy? Right? Based on your previously known data, you know who bought, who didn't. Now you want to do predictions. So that's classification. Clustering is similar, but you don't know. You don't know the classes already. You want to come up with classes. That's called clustering. There's two types. Well, there's more actually, but the ones that we focus on are two. Association rule learning. That's kind of like understanding if somebody already did like shopping baskets, how they add more stuff into your basket, or recommend stuff. That's association rule. So Amazon probably uses one of these. I'm not sure. Reinforcement learning, really fun thing. I love reinforcement learning. There's two here. It's in my view, it's the killer of the A/B test because you can I'm not going to go into detail now, but you can do a lot of things with reinforcement learning, real time. Reinforcement learning is kind of like probably that's kind of the basis of AI, of artificial intelligence. So this reinforcement learning, it's easier to jump into robots and things like that. Natural language processing, that can be from audio, that can be from text, sentiment analysis and things like that. Deep learning, who's heard of deep learning? Okay, that's the neural network. When you reconstruct the human brain to kind of reconstruct the human brain, similar concept for it to learn on its own. So you don't have to give it parameters, it'll learn through observation. Dimensionality reduction, not going to go into detail on that now. And model selection boosting, so that you got XGBoost, a very powerful way of boosting models. Or like picking models and creating models. Anyway, so that's just to show you the world of machine learning is huge. If you thought the world of data science is huge, the world of machine learning is like enormous. Who's heard of Udemy? Udemy. They're here in San Francisco. Yeah? A lot of you have already done some of the courses on Udemy. If you Google machine learning on Udemy, you'll find 3,463 courses on machine learning. Ours is this one at the top, but the point is you can just click on it and look at the structure. You don't have to buy it. You can just go and pick out those specific topics that you want to learn, and you can learn from these other courses are also great by Jose Portilla and Frank Kane. I've met Jose in person. I've met Frank with great courses as well. Or you can just go find YouTube videos, online videos, and just learn that specific topic that you want. But basically, what I'm saying is that in our course, we created this glossary of machine learning, which you can always reference even without taking the course, just to understand, okay, what's the next thing for me? What's the next thing for me? And so on. So that's Udemy, that's machine learning. Top 5 tips. Okay, number 1, focus on intuition. This is one of my favorite tip about data science and machine learning. Machine learning might sound scary. Who felt a little scared looking at those slides? Don't be afraid to put your hand up. They scare the Jesus out of me. Probably not the right saying, but anyway, machine learning, super complex. So if you're not scared, props to. But focus on intuition. Who knows in a car? Who knows? Tell me, who knows here the difference between a crankshaft and a camshaft in a car? Put your hand up. Okay. Who knows how to drive a car? Put your hand up. You see the difference, right? You don't need to know the difference between a crankshaft and a camshaft and all these other things to be able to drive a car. All you need to know is, all right, how do I put the petrol in? Where is the seat belt? And what's the gas, what's the brake, and how do you turn the steering wheel? That's all you need to know, more or less. And so basically, that's the intuition, in my view, of how to drive a car. Your body already tells you, after some experience, you already know what to press, when to start braking. You know how to park the car after, in my case, you bumped a few other cars. You learn, reinforcement learning. But anyway, so that's how the intuition and the practical applications. You actually drive the car, you know how to get from A to B. Same thing with machine learning. Who said you need to know the mathematics behind machine learning? I don't get these people who try to teach. If you're a researcher, I get it. If you're doing a PhD, or if you want to create new machine learning algorithms, or if you're doing your master's degree or something like that, you probably need to go through the pain of learning this stuff. But if you're just using machine learning, why do you need to know the mathematics behind it? There's no point in it. Seriously. You might, if you're interested and curious, you might go in and open your car and understand how the engine works, or where the timing belt is, and what a crankshaft is, whatever. But you don't really need it. Same thing with machine learning. You just need to know the intuition behind things. What does it actually do? What is the Bayesian? What is Bayesian inference, and why is it different to the normal probabilistic approaches? It takes you 20 minutes to learn that. And then you just practice, with a car driving. You know the intuition, you know where to put petrol. Now you just practice driving and practice the machine learning algorithms. You do 2, 3, 5 times, and you got Bayesian classification mastered pretty well. You can go and apply it. And at the end of the day, what do you want? Do you want to create a new machine learning algorithm, or do you want to add value to a business and have fun with it? I think it's the second, the latter, right? Or 90% of the case, the latter. So don't be afraid of machine learning. It's a fancy word, the algorithms have fancy names, but ultimately, if you understand the intuition, that's what we focus on. I very rarely go into the mathematics in our courses, and people who've done our courses will confirm this, right? You see a lot of nodding heads. I rarely go into the mathematics. I focus on intuition, Adlan focuses on the practical stuff, and that's how we create our courses, because that's all we believe that you need to be successful. Tip number 2, consider ensemble methods. Ensemble methods are when you have several algorithms working together. For instance, you might have one decision tree. Who knows what a decision tree is? Cool. So a decision tree, that whole thing, that's one algorithm used in machine learning. But it might be good in some cases, but overall it's not going that well. It's a very simple type of classification method. But what you could do is you could have 100 or 1,000 or 10,000 decision trees working at the same time with slightly different parameters. Or actually, it can be the same parameter, but they were the same decision tree, but they were trained on different subsets of the data. And then you end up with 1,000 decision trees working together, and you get them to vote, like a democracy of trees. It's called a random forest, literally. That's the name of the algorithm. Random forest, and basically the outcome that gets the majority vote is the correct outcome. And so in that case, you benefit from more stability in your algorithm. So consider ensemble methods, and you can actually mix in algorithms. And you can do a decision tree, a different algorithm, take 4 different algorithms, or 40 or 100 of each, but then mix them up, and then get your answer. That's an ensemble method. Those are very powerful. Learn R and Python, or Python and R. Some people focus on one. Who's a fan of Python? Who's a fan of R? See, I know who's a fan of both. Good, everybody should become a fan of both. You go better for your resume, better for your skills, better for your overall view, and also better for understanding the intuition behind the algorithms. If you understand in Python, and then you do it again in R, it's a bit different, the code's a bit different, and you dig deeper, and you're actually, all of this whole presentation is assuming you're passionate about data science. If you're passionate about this, you're gonna have fun understanding the details. It might be hard at the start, the learning curve might be steep, but once you get it, you're gonna have a lot more fun if you know both, or learn both at least. Play around with deep learning and artificial intelligence. That's where the whole world's kind of going. You want to be there, right? If everybody's going that way, you want to be there first. So highly recommend checking those out. And have fun. Don't just do it and hate it. If you're hating it, you choose a different algorithm. You should be having fun. Ultimately, what does Warren Buffett say? That he's a billionaire, right? It's an investor and helps people and things like that. But he says that he hasn't worked a day in his life because he doesn't consider it work when he's having fun, right? That's what we want for all of you. Everybody should be having fun, not slaving away. If you're not having fun, something must be wrong. Okay, top 5 tips for stage 3. Focus on intuition, consider ensemble methods, learn Python and R, play around with deep learning, and have fun. Have lots and lots of fun. Okay, 3, 2, 1, hold on a second. Here we go. Stage 4, visualize the data. All right, we're more than halfway. Okay, how about we get up and do a stretch? Yeah, everybody, get up. Come on. We need the blood flowing, and this one needs some music pumping. Not good at that. All right, stretch up, side. Guys watching online as well. Left, forward. Okay, high 5. 3 people around you. Go. All right, come on. Having a great time. Everybody's learning a lot. Yeah, awesome. Okay, thank you. Thank you. Let's continue. Awesome. Get some energy in there. Number 4, visualize the data. All right, 2 types here. Visual analytics and visualization. I personally like to distinguish between the two. You'll see why just now. Visual analytics. This gentleman over here, his name is Emanuele Carbone. He is in Italy. I think he's in Florence. Very interesting story. We met Emanuele over here when Adlan and I were doing our roadshow last year in summer. We went in July. We went across 7 or 10 countries in Europe, and I think we had 7 catch-ups with students in different locations. And this was a catch-up in Florence, and Emanuele is there in the middle. And there I learned the story, and then I invited him to the podcast. So Emanuele is he's like, I want to do data science. This sounds like a really cool thing. I want to get into the space. How am I going to do it? And what he did is phenomenal. he actually started, and I'll tell you the details just now, but overall what he did. He started approaching companies in his, so this is for people who wants to actually start like a freelance career in data science. He started approaching companies locally, but you can also do that online. You can use something like Upwork, which is an online freelance platform, and you can do that online. But anyway, he started approaching companies and saying, hey, I can do, data science is pretty cool, you guys have data, you're probably not using it, I can help you, and I'm not going to charge you anything. I'm just going to analyze your data, I'll sign an NDA, non-disclosure agreement, and then I'll give you the insight. Tell me the problem, I'll analyze your data, I'll help you solve it, and then I'll give you the insights. If you think that's valuable, you can pay me. If not, you keep the insights, you don't pay me, and we, part ways. He did that, and now he's, last time I heard, he's working with a local restaurant, helping them do data science, because they loved his insights, and they right away, we want you doing more. And they obviously paying him. Then he's working with one of the, I think it's like a football club or a football betting association or something, one of the biggest ones, like top 5 or something like that in Europe, and they're like Italy based. And then another company. So he's working with 3 companies, a freelance consultant in data science, working his own time and hours. He's very young and super successful in that sense. And this is the catch. It took him 1 year to do that, and the tools that he uses are Excel and Tableau. There's no Python, there's no R, there's no machine learning, nothing else. Everybody knows Excel, and Tableau is a super simple drag and drop visualization tool. You don't even have to learn to code to use Tableau. That is how powerful data science is. When I heard this story, the thing that, the instant name that came to mind was golden age of data science. We are in the golden age of data science. Once upon a time, there was a golden age of accounting, when accounting came in and disrupted businesses, and the businesses that had accounting were more successful. There's a golden age for everything, but they've passed. Those professions are now structured, and the education for them is structured, and you have to climb a corporate ladder. Right now, in data science, at any age, at any walk of life, you can just grab these 2 tools. It's simplest word, any 2 tools anyway, for that matter. Let's say these 2 tools, and you can build yourself a career within a year, probably faster. How cool is that? So speaking of Tableau and data, keep forgetting, visual analytics, right? So Tableau can be used for visualization and visual analytics. We're talking about visual analytics now. So this is from our, who remembers the Data Science A-to-Z course, yeah? So from the Data Science A-to-Z course, this is us just, we're analyzing data for some bank, I think, and then we're like, okay, so let's have a look at the distribution, different, what is this? These people who stayed and exited in this one. These are people who stayed in the bank, the blue ones, and the orange ones, the ones that exited over a certain period of time. And the top one is the age. That's the distribution by age. This is, you can see 15 to 20, 20 to 25, 25 to 30. And so you can see that the age distribution is kind of like a normal distribution, which way is it skewed? Right, left or right? Right skewed, correct. Yeah, you look at the tail, not the main part. Right skewed normal distribution, which you kind of expect. That's especially if you cut it off at 15. And here is how they leaving. So this already, if you do this is taking us back. This part, visual analytics, is taking us back to that identify the question phase. Remember we talked about seeing your data. So this is allowing you to have a glance at your data. It's not clean. There might be errors and so on. But it gives you a feel, and you're like, oh, interesting. The age is skewed. The age is skewed there, but more people are leaving here, right? So how come? Why? And this is in percentage terms. How come more people leaving at this age? Maybe some other bank is hunting them down. They have a better product for insurance, for health, or life insurance that we don't have. Or maybe it's opposite. Maybe actually our bank is doing well with the younger generations, younger segments, because we have something that is, maybe we have a no interest loan, and maybe we should target them more, right? So it already gives you ideas. You're thinking, oh, what could it be, and so on. And when you have those conversations, you haven't even started the project yet. You're still understanding the question. When you have those conversations, all of a sudden you have so much more power in your hands. You have something to already contribute to the conversations with the people you're having. Imagine your CEO of the bank comes and asks you to do this analysis, and before you're like, okay, can you give me 2 days? I'll just need to poke around and understand the question a bit better, and then I'll get back to you on the project timelines and scope. And then next day you come back to him and you say this, he'll be like, whoa, already? I didn't even know that. And imagine, and then he's like, "Man, if you did that in one day, what can you do in like a week or a month?" It's like you're gonna have a much more productive conversation. So, and all it is that the data is already saying this. All you're doing, the difference is you're seeing it. Because when it's in a spreadsheet, try seeing this in a spreadsheet. You're gonna shoot yourself, right? Like you can't see that in a spreadsheet. You can see this on like in images. All you're doing is putting it into images. That's why visual analytics is so powerful. And that's why Emanuele is able to create a career out of it, because he has that super powerful advantage that it's a tiny learning curve to use Tableau or a similar tool. There's Tableau, Power BI, ClickView. Those are the top three. Microsoft is Power BI is from Microsoft. It's a free tool as well. So very tiny learning curve, a tiny extra step you need to take gives you a huge advantage. You know who knows the 80-20 rule, the Pareto law? Like 80% of the causes come from 20%. 80% of the effects come from 20% of the causes, right? So you do a little step, you do 20% of the learning, but you get 80% of the results, right? You find those parts, and visual analytics is one of them. Now visualization, different. Same tools, same kind of idea, but a lot of people don't distinguish between. I think distinguishing between them is important, because this one comes at the end of your project. That one came at the start, this one comes at the end. Visualization, Nedi Bremer from Netherlands. Amazing freelance consultant in the space of visualization. So here's one of her visuals. This is how in the US, countries actually, cities, bus the homeless people to different cities. I didn't know this was happening. Like where's San Francisco, somewhere there. So apparently what you guys do, because San Francisco is the biggest one. Oh no, there's a big one here. So the government in San Francisco puts all these homeless people on the bus and sends them over to Florida. And in Florida, they put them on a bus, send them to San Francisco. Or it gets ridiculous. So these are by the year. It's quite intuitive visualization, and it's actually interactive. It was published at The Guardian. I recommend checking it out. It's pretty cool. You scroll down and it adjusts and shows you these buses going and stuff like that. It gets ridiculous. One lady was flown from the US to New Zealand. Why? She had like ancestry there or something like that. Like you guys fly people out overseas and so on. So interesting, like data can tell you interesting stuff, and she visualized this whole thing, and like you can see it gets ridiculous, right? Like why are they shipping them to each other? It's don't know. Anyway, so that's one of her visualizations. Very beautiful. The website, if you want to check it out, is called visualcinnamon.com. Amazing visualizations. You can get a lot of inspiration there. This of course is a much more it's a difficult tool that she's using. I think this one's called D3. It uses JavaScript. It's quite complex to use. But like if you're an artist, I did a bit of D3 work at Deloitte, and I did it we were like having a D3 battle with one of the directors there, like who gets a better visualization. I was just like having so much fun, like when you love something, you learn it anyway. So who knows this visualization? Ooh, okay, good, because you should know this visualization. It's Charles Minard's one of the oldest visualizations in the world. It's a visualization of how the French army with Napoleon invaded Russia in 1812. All right, so I told you that, right? France is there, Paris is there. Well, that's not Paris, it's the edge of modern Latvia, where they kind of started the campaign. Moscow is there. Just look at it, and without me telling you anything else, and it's all in French, so I know you're not cheating. Without me telling you anything else, can you already kind of guess what happened? What went down? What is this visualization telling you? Yeah, who can kind of see? Who thinks they know what's happening? Okay, what if I tell you? So that's where they started. That's where they went. I'll tell you the story. So Napoleon attacked Moscow. It was very, very cold, and they were all like marching through the snow. It always happens in Russia. Napoleon attacks, it's freezing. Germany, Hitler invades, it's freezing. It's like nature is not letting anybody invade. But anyway, so he got to Moscow. What Moscow did, people in Moscow did, they just left the city. Then he's like, I win. And like, what do I do next? And he's like, okay, let's go back. And he went back. And then like the Russians started like attacking, like not letting him go back fast enough. So the width of this line here is how many troops he had. So over there, he started, I believe it was like, what was it? 400, there we go, yeah, 400,000 troops at the start. And over here, what you have is how cold it got, degrees below zero, -5, -10, -30 in Celsius, so that's a ton lower in Fahrenheit, so freezing. And then you have like different cities, and you have different little comments. And somewhere else here, there was the different dates as well where he went. But anyway, the point is that that's the size of his army dwindling down to 100,000 when he got to Moscow. So that's like a quarter left. And then when he got back, only 10,000 people made it back. So you went from 400,000 to 10,000. And so this visualization not only shows you why this is a popular visualization, there's more. So you've got the direction where they were going. You've got the size of the army. You got how cold it was. You got the different cities where they were, and you got the direction. You got like orange, brown is like right, and black is left. So very telling visualization, and this is a good example. Like there's a good book. What is it called? ggplot is our library. When I remember the book, I'll tell you. Grammar of Graphics. That's what ggplot stands for. ggplot stands for Grammar of Graphics. The Grammar of Graphics talks about this visualization. I highly recommend checking, like reading it, understanding a bit more how to build their visualization. Anyway, so just to show that there are really cool ways you can visualize data apart from just like the simple things that we come to. But nevertheless, even with tools like Tableau, you don't have to go D3 or you don't have to like sit and draw like Tableau. With tools like Tableau, like you can put a visualization like this together in like 20 minutes. And this is not just like 30. This is not just a visualization, it's an interactive visualization. So again, same bank, analyzing their customers, they're in the UK, and now you can click on blue collar workers, the whole thing updates. It shows you the gender split, shows you the number of percent of customers, like what do you call it? Distribution by age, location, everything. You can click on any one of these parts and it's interactive. How cool is that? So this is not just like analytics, visual analytics. This is actually, you're preparing a dashboard for the executive. You remember at the start you did some visual analytics, you got some insights. Now you've done the project and this is your end result. This is what you're presenting to the executive or to the CEO or to the board of directors. And now they can click around and they have this tool that is like now self-service analytics. Now they can go through the tool and find their own insights. Or you don't have to make it interactive. You can just like print something like this out, and there's already a lot of value there, right? So that's part of visualization. Again, with Tableau, you can create this very, very quickly. So good to know. If, like in Excel, this would take a month, probably in R or Python, that would take you a week to create. Wouldn't be as interactive unless you're using something like Shiny. But in Tableau, 30 minutes, you got this thing done. So know your tools and know that you can create amazing visualizations. Top 5 tips. Number 1, keep the problem in mind. Going back to the beginning, don't forget what actual question were you answering. If the question you're answering is not in visualization, then what's the point of your visualization? Keep the problem in mind. Limit the amount of text in your visualizations and in your presentations. And so a lot of these things, especially now going into this part and the last part, you will notice that what you're seeing in my presentation is kind of like I'm applying these tips. Like you can see that throughout my presentation, the amount of text is limited. Like before, when I was doing it, putting it together, I had the tips all on one slide right away, but then I was like, that's too much text. You guys are gonna start reading, right? Even if I put them one by one, by tip number 3, you're gonna have too much text to read through. I don't want that. Like I want you to focus. The main thing, we'll talk more about this, but I'll say it now already. The main thing is your presentation, unless you're sending off an interactive tool for somebody to work with, well, that's the only case when this is not true. But if you're presenting, your presentation is assisting you, not the other way around. If I was standing here and you were reading my slides or going through my visuals, trying to figure out it, like this would be useless. I want you to focus on me. This is like glance back here. So limit the amount of text. When people start reading text, whether it's a presentation or interactive tool, they're not listening, or they find it too difficult. It must be very quick. They must be able to get the main insight within like glance, like 3-5 seconds. They must be able to understand what's going on. Guide your audience. So with your visuals, make sure they're focusing on the right things, right? Use colors to highlight the insights that are important. Use other things. Keep everything simple. Don't overcomplicate. You might want to create a super cool visual design. Simple is better. Less is more. And finally, add context. Here's an example. Imagine a country that their pollution levels went down, whatever this means, from 17% to 14% year on year, right? So the local news might say, hey, our pollution levels went down by 3%, amazing, we're doing a great job for the environment, right? So that's positive. But now the international news or their neighboring country might say, this country's pollution levels are 14%, but the average, world average is 12. So it's negative, right? Context gives meaning. Data without context is nothing. So you gotta understand, based on the problem that you answer, it doesn't mean manipulate your presentation to suit the needs that you want. No, but understand the question that's been asked and add the right context. Add the context that's gonna either highlight a problem or like focus people's attention on the right thing rather than leading them astray. Top 5 tips, stage 4. Keep the problem in mind, limit the amount of text, guide your audience, keep everything simple, and add context. Okay, last one. Ooh, present your findings. 80-20-80, remember? The other big part of your work. All right, so here we've got Greg Poppy. He's a friend of mine in, I think he used to live in LA, then he moved to Miami. I'm not sure exactly. That tells you what kind of friend I am. Don't even know where he lives now. But anyway, he works for risk management. He does risk management for financial services, so when companies lend credit. And one thing that I enjoyed, it was also in the podcast, one thing I enjoyed in sharing was when he does model, when he creates a model for, those machine learning stuff we're talking about, when he's creating a model, he already keeps his audience in mind at that stage. He's like, okay, I could do a model and I could put something like a logistic regression in there, or like a decision tree, but no, let's say I could put a decision tree in there, and it would work, but it'll be hard to explain to my audience, because those things in the decision tree, try explaining that. It's like, it just finds these patterns and it's really hard to explain, really hard to interpret. So it's like, it's gonna be hard to interpret, not only to my boss, but they sell these models, or they sell these models as a service to, let's say, car dealerships. The car dealerships punches the numbers in, and they can see, whether they should lend the credit or not, and how much they can lend. Well, it's not going to be useful if the car dealer punches in, annual income of $100,000. It says lend the credit, and then it punches in like $99,000, and it says like don't lend the credit. Like there's no, and then 98,000 like lend the credit again. It's like doesn't make sense. It has to make sense. So he specifically chooses models that he can interpret and explain to his audience later on. Another important stage, just keep in mind what you're going to be presenting throughout the whole process. And here we're going to jump straight to top 5 tips, because that's where the value is. So now, know your audience. And that is part of what Greg does, but also just understand, are they technical? To what level can you present to them? How can you engage them better? What exactly, what kind of questions are they going to be posing? Like knowing your audience, and that's why talking to them throughout the project is actually quite important. State the problem and benefit early. Remember at the start, I told you that we're going to talk about the data science process, and that there's a problem that there's many types of data science process and there's no structure. And then by the end of this presentation, you'll have a structured approach in your head. So that was showing you the problem and the benefit at the start, right? Rather than you having to wait, like, why am I sitting here? So tip number 3, use clear, jargon-free language. Remember, the people you're presenting to are not data scientists, most likely, and they will not understand super technical things. Tip number 4, tell them a story. Like in this presentation and most of the ways like I like to present is you don't just like roll hard facts, but you actually tell them, remember the story of Ulf Morris about the 42 million to 2 million, right? You're not going to forget that. That will help keep that knowledge in your memory. In fact, and like each one of these had stories. But in fact, like I saw a presentation recently, like a TED talk kind of, or something similar, where this lady was saying that when we're just exchanging facts, only 2 areas of the brain are engaged. I forgot what they're called, but like the area of the brain that is responsible for interpreting language and changing it into data, and the area of the brain that's responsible for generating language. That's all. But if you're telling a story to someone, all of a sudden their imagination switches on, and like more than 5 areas of the brain are working. The part that is like visual images. You're like, when I was saying that story about Ulf Morris, you were thinking, okay, so that was, what was it? Data preparation. So you were thinking about 40 million, 2 million, 3 companies, 5 companies, what are they doing, how they're interacting, Other areas of the brain, like so visual, you might hear things, you might even smell, like if we're talking about flowers or something, or then, you might be able to like feel something, right? So more areas of brain engaged, you're going to retain that information better and understand it. And finally, keep them engaged. Get them to stand up, do a stretch, or ask them a question, get them to laugh. That's the best part. Like when you get people to laugh, that means they're with you. Okay, top 5 tips. Okay, know your audience, state the problem, you add benefit, use clear jargon-free language, tell the story, keep them engaged. Okay, so to recap, there's our data science process. Identify the question. All right, let's go. Who remembers number 2? Read the data. Who remembers number 3? Analyze the data. 4? And 5? Present your findings. There you go. Engaging the audience, right? Okay. So that's our data science process. Went through all 5. We're gonna have a Q&A at the end. Podcast episodes, as I promised. If you want to take a photo of this, so there's a podcast. If you haven't listened to it yet, Super Data Science. It's on iTunes and Stitcher and other places. These are the episodes we talked about. These 2 at the bottom we haven't spoken about yet. That'll be in the bonus part, but still I include them because they're cool episodes. So if you want to take a photo and then go check out these episodes, I recommend. Okay, 1, 2, 3. And hope people online are still there, because now we got the bonus time. So thank you so much for coming today. I really appreciate you guys being here. And so what I wanted to share was I wrote a book. It took me 1.5 years. It got published in January. And this really is a book that's like, the publishing house contacted me and they're like, you have courses, do you want to write a book? I was like, I don't want to write a book. Like, I've heard how much time and effort it takes. And it was a lot of time and effort. But then I thought it would be cool, actually, if we wrote a different book. And they're like, oh, let's do a book in R or Python. So it's like, no, there's enough of those books. This book is just intuition, just data science, and all the stuff we talked about, but in more detail. So it's based on the data science process. The 5 parts are, what goes into the core, the structure of this book. And there's no code. So basically, you can read the book on a train or on a plane or wherever, and just understand all these things, algorithms, whatever it means for your career. Anyway, long story short, I want to give you this book for free. There's 200 books that we're giving away. Like, there was 50, but then a lot of the organizers told me that we had like 150 people watching online, so we upped it up. There's 200 books that we're giving away. All you have to do is send an email to support@datasciencego.com. In the email, send me my book in capital letters. You can add exclamation marks at the end if you want. Then in the body, say your postal address, and you need to do this by Sunday. So there's no catch. We won't request you to do anything. This is absolutely yours. I'm really passionate about this project, and I want to popularize the book. So the only thing I can ask is, if you like it, don't just keep it on your shelf. Give it to a friend or a colleague, or lend it to them so that they can learn a bit more, so they can go through these steps. Like, data science community is really sharing, giving. Support that. So we're going to be sending those. Make sure to send that by Sunday. And the other thing that we want to give you as well is, as mentioned, we have the Data Science Go conference happening in October this year. It's in San Diego. I know it's not in San Francisco, so it's a bit of a stretch. But we're giving you this a voucher, which is again on the screen. It expires on this Sunday, but basically with this coupon code you can get 25% off if you want to come to our conference. We're going to have 25 amazing speakers there. So I'll bring the slide back up in a second so that you can keep it on. But basically we're going to have 25 amazing speakers to the event. I hand selected every single one of them. Some of them have been on the podcast, some of them are coming on the podcast. And each one is really cool. So basically it's not a technical event. It's not just data, science, technical side of things, and machine learning. It's people sharing their stories and successes. So here's some examples. So it's me, Adlan, Fabio Vasquez coming from Mexico. Who knows Randy Lam? Yeah, who's seen really popular guy. So he went from 0 followers on LinkedIn to 45,000 in 1 year. He's a data scientist who shares his journey and how he really highly recommend checking Randy's podcasts, like blogs and so on. Tari Singh coming from Europe, Sinan, Ben Taylor, AI, then Dee Bremer, who we talked about today, then Shibla from Twitter. Basically, that's some of the speakers. They're coming, there's more, didn't fit on this page. I'd like to show the video now, is that okay? Sorry, do you mind helping me out, please? So I'm going to just show you a video of what happened last year. So this is our second year running the event. And wanted to get you a bit excited. Remember the stretch we were doing and the high fives? So yeah, you're going to be doing a lot of that there. It's an event that
Data science has a great opportunity to change the world.
Yeah?
Data science has a great opportunity to change the world.
I'm actually not in data science, but I want to be.
Things change over time. They always change, just like data does.
Data now is everywhere. It's all around us.
What makes data science what it is the fact that there's so many different fields that are intersecting at data science.
Businesses can make decisions about the future.
I'm excited to meet lots of new people and learn things that they're doing that I can take back into the work that I'm doing.
I got a lot of value. There was a lot of good points each of the speakers made.
I think this is one of the most useful conferences for anyone that wants to get into data science.
Yeah. So there you go, by the way. There you go. You went last. What did you think? Yeah? What was your favorite part?
This is inspirational.
Yeah.
Little practice sessions.
Kyle sees that. Yeah, it was fun. Yeah, so, yeah, thank you. Wait, could you put the slides back up, please? What? The slides.
Slide? Okay.
Yeah, so yeah, we'd love to see you all there. Basically, yeah, so I wanted to show you this slide here. So these two guys right here, they were attendees at the conference. And so Neelab was already kind of like into data science, machine learning. After conference, he's grown his career. I can't say this is 100% attributed to the conference, but he's now got a job as a data scientist at Walmart, and he's going to be coming back as a speaker. So you can see he's a speaker this time. And Rico Meidel, he was a student, had not much to do with data science. Now he's organizing his own meetup in Germany. He lives in Germany. He's about AI. He's introduced AI into his company. He got so inspired. At the conference, he was like, I want to be a speaker next year. I told him, well, you first have to prove that you're good enough. And like he went away, and like within 3 months, he did so much. I was like, yeah, you have to come back as a speaker now. So yeah, so they're coming as speakers this time. Yeah, that's the conference. We'd love to see you guys there. And what I wanted to show you with these like examples and some of the examples that we had before, let's say Randy's coming as well, that it's some of these stories that we talked about, they seem as they're like, you can't reach them. They're like up there and you know, it's impossible to get there. That's not true. Like these guys, Randy, a lot of people went from 0 to hero, or like Emanuele, right? It took them a year. It's like, that's all it takes, maybe less time. It's all possible, and you can also all be there. And that's what our event's about. It's about helping you guys get there and helping each other out and building this community. It's not just an event, it's a community of data scientists. Okay, so I'm just gonna leave this slide on here so you guys can see it. But that's all. Thank you very much for your attention today. I hope this was helpful and useful.